In the question number 36, which of the following volume VT graph represent Carnot engine cycle? In this type of question, I would like to suggest one thing. You can memorize this thing. In the Carnot cycle, consists of 4 steps. Number 1, isothermal expansion. Number 2, adiabatic expansion. Number 3, isothermal compression. And number 4, adiabatic compression. I would like to repeat: isothermal, adiabatic, again isothermal, then adiabatic. So when you will observe in the process number 1 or graph number 1, you will see when you will move A to B, then there will be no temperature constant. तो ये नहीं हो सकता, इसको reject करो. If I go for option number 2, I need isothermal A to B. Temperature is constant by the graph, yes. And need second मुझे जाना है B to C, adiabatic expansion. ये देखिए एक्सपेंशन हो रहा है वॉल्यूम में, यस, ये भी फॉलो कर रहा है. नेक्स्ट है CD में मुझे टेम्परेचर कांस्टेंट चाहिए. C to D टेम्परेचर रिमेन कांस्टेंट बिकॉज टेम्परेचर इज ऑन एक्स एक्सिस, एब्सोल्युटली करेक्ट. एंड DA आई नीड कंप्रेशन इन एडियाबेटिक प्रोसेस. Yes, this is given. So easily you can find option number 2 are ready to fulfill the conditions. So I am going to select my option number 2 will be the right choice. So let's move on question number 37. In the question number 37, the volume of a polyatomic non-linear molecule. Gas varies with its temperature T. The ratio of heat absorbed by the gas to the work done by the gas when gas is taken from state A to B, neglected vibrational mode. Okay, we know Q by the first law of thermodynamics, delta U plus W, right? And one thing I would like to say, you can write in place of delta U mu Cb dt. In this time, you have one doubt. Can I use this in general form? Yes. If you have ideal gas, you have to be very careful. If you have ideal gas, then if temperature is constant, in the case of ideal gas, if volume is constant or not, you can use this relation in place of delta U. But this is valid only for ideal gas. So, and W means work, mu R delta theta. Delta theta is the temperature change. Now, so when another thing Cb, because polyatomic, so you can use Cb is equal to 3R, you know very well. So I am going to place the value mu 3 and another one is mu Cb d theta. I am going to use d theta because here I am writing d theta. D theta means temperature difference. So I will write mu into 3 R into d theta plus mu R d theta. So the total amount of heat will be 4 times of mu R d theta. This is Q. And another thing is work. You know work is mu R d theta. This is equation 1 and this is equation 2. And question is asking to us the ratio of heat absorbed by the gas to the work done. So when you will take the ratio between these two, you will get Q upon W. I am writing Q for heat, 4 upon 1. So my final answer will be 4 ratio 1. So I can select my option number 4 will be the right choice. Let's move on question number 38. In the question number 38, an ideal diatomic gas undergoes a polytropic process described by the equation. So this equation I can write Pb 1 by 2 is equal to constant. The molar heat capacity of the gas during this process. So you know in the polytropic cases, if you are looking to find more heat capacity, then you will use the formula Cb plus R upon 1 minus N. And how you will calculate Cb and N? You know Cb is calculated by Fr by 2. F is the degree of freedom. N, how you will calculate N? If any process just like Pv to the power N is equal to constant and N is not going to match the value of gamma. So this is called polytropic process. So when you will compare these two equations, you will get the value of n is 1 by 2. Now I am going to place the value CB because degree of freedom will be 5. So I will write 5R by 2 in place of CB and plus R upon 1 minus 1 by 2 because you have the value of n is 2. So when you will calculate, you will get 9R by 2. So this is our final answer. So I can say my option number 1 will be the right choice. Let's move on question number 39. In the question number 39, a refrigerator works between 0 and 45. It is required to remove 2000 joule of heat per second in order to keep the temperature of freezer constant. The electric power required is about. You know the coefficient of performance, and that is K Q2 upon W. So let's say how you will find the value of K. You can K means lower temperature, means sink, higher means source, and that is equal Q2 by W. You have only one doubt how you will decide Q2. So we'll see. First I am going to write the value of lower temperature, that is 0. So you will write 0 plus 273 in terms of absolute. Higher temperature 273 plus 45 minus lower temperature 0 plus 273 and on the another side Q2. Question में दिया है कितना remove करता है, removing part is Q2 and you can understand 2000. So you will write here 2000 and divide by W means power. So 273 and 273 you can cancel. So power P is equal to 2000 into 45 divided by 273. Approximately you will find 330 watt. So I can say my option number 3rd will be the right choice. Let's move on question number 40. In the question number 40, in the given pressure PT diagram, what is the relation between volume V1 and V2 for a fixed mass of a gas? Because we know PV is equal to mu RT. So if I write only P, mu R divided by V into T. For a given temperature, I would like to say that at a constant temperature, we can find pressure is inversely proportional to volume. Now I am going to see the graph. By this graph, if you look theta 1, theta 2, PT, then you can observe that P2 is greater than P1 at a given temperature. There is no confusion. So if P2 is greater than P1, so if I use this relation, I can say V2 is less than V1 easily. So I can find my answer. So option number 1 will be the right choice. So let's move on question number 41.